Good morning 11th class. Today we'll study about shapes of orbitals. Now you all are familiar with orbitals. So now we have different orbital S, P, D, F. So what about the shape of these orbitals? कि किस shape के होते हैं? Okay, that I'll explain to you. Okay, now before I'll explain shapes of orbital, we have 2-3 types of questions based on quantum numbers. Okay, so first I explain that. After that I'll start with shapes of orbital. Okay, now just see, our first question is using the SPD notations. It's not only SPD, it's a SPDF notations. Describe the orbital with the following quantum number. You have to describe this orbital with the following quantum number. Just see, first one is given, n is equal to 1, L is equal to 0. Second, n is equal to 3, L is equal to 2, like this. Now in this one you have to describe the quantum number. How to describe? Now just see, n is equal to 1. Okay, n means principal quantum number जो हमें क्या represent करे, that one represents number of shell. Okay, if n is equal to 1, it means we are talking about first shell, and L is equal to 0, it means we are talking about subshell. Which subshell? S. Okay, so when you write it, okay, so your answer is 1s. Just see, 1s. Similarly, second one, it's a 3 shell, it's a 3, and L की value 2. It shows what designation क्या आ जाएगा? D, S, P, D, F. 0, 1, 2, 3 and 4. Okay, so this one is 3, and if L is equal to 2, okay, the answer is 3D. Now just see third one, n is equal to 3, L is equal to 1, it means 3 and P. Then D, that one is n is equal to 2, L is equal to 1, so this one is 2, and this one is P, so your answer is 2P. Here next one is n is equal to 4, L is equal to 3, so this one is 4F, and last one is 4D. Okay, like this you have to solve question. This one is one pattern. Now you have one more pattern. Just see, that is list all the values of L and M for n is equal to 2. Okay, you have to write all the values of L and M for L is equal to for n is equal to 2. Okay, maybe simple this type of question is given, and maybe you have to write number of electrons when n is equal to 2, so accordingly you have to write. Now just see, for this how to write n, this side L and M. You can write separately one by one, एक दूसरे के साथ next step में भी लिख सकते हो, but n is equal to 2. Then if n is equal to 2, so what about value of L? Okay, it's 0 and 1. Remember that formula, 0 to n minus 1. The value of L is 0 and 1. And for M, this one is, you can write it's a ML. Okay, so when value of L is 0, ML is also 0, but when value of L is 1, okay, so this ML is minus 1, 0, plus 1. Okay, so these values are possible for L and M when n is equal to 2. So accordingly questions are there. Now 11th class, this okay, after these questions, okay, the next thing is, that is shapes of orbital. So we have 4 orbital, S, P, D, F. In case of S1, only 1 orbital is present, P 3 orbital, D 5, and F it's a 7. Okay, so first of all, shape of S orbital. Okay, so in case of shape of S orbital, actually it is spherical in shape, and if it is spherical in shape, it means direction is, okay, there is no direction because it's a spherical in shape, so it is non-directional in nature. Just see इसका structure कैसा लगता है. Okay, now this one is diagram. Okay, just see 1s orbital. So this one is spherical in shape. Now just see, nucleus and first orbital is merge. Okay, no, there is no nodal plane. This one is simple 1s orbital. Okay, so this one is spherical in nature. Even if you will see 2s orbital, so just see this one is shaded portion, this represents orbital, and this white portion represents node. Node where the probability of finding electron is 0. Okay, and this shade is orbital, means where the probability of finding electron is maximum. Okay, so this one is, it shows what, that one is shape of orbital, that one is a spherical and non-directional. Okay, now second we have, that one is shape of p orbitals. Okay, actually in case of p, okay, subshell, there are 3 possible orientation. okay, corresponding to ml is equal to -1 0 plus 1 values, that is 3 p orbitals in each p subshell. You know, in case of p subshell we have how many orbital? 3 orbitals we have, and they are designated as px, py and pz. Okay, px, py, pz means they are, okay, along with x-axis, y-axis and z-axis. Now in case of p orbital, the shape of p orbital is dumbbell shape, because we are talking about shape, तो मेनली वही है कि दे आर डम्बेल शेप. ओके, डम्बेल शेप जैसे डम्बल्स होते हैं, सिंपल एक्सरसाइज वगैरह के लिए यूज़ करते हैं, दैट शेप. ओके, सिंगल लोब्ड डम्बेल शेप, दिस वन. ओके, नाउ जस्ट सी, सपोज x-axis, okay, one side is y-axis and one side it's a z-axis. Okay, so this one is x px, okay, and because p orbital start with 2, okay, so it's a 2px, this side it's a 2py and one is 2pz. all these are p orbitals, px, py and pz. Okay, now another one is shapes of d orbital. Now just see, in case of shapes of d orbital, you know, in case of d subshell, how many orbitals are possible? 5 orbitals are possible, and they are designated as dxy, dyz, okay, this one is dyz, dzx, this one is dzx, dx square minus y square and dz square. Okay, 5 orbitals are possible. Why? Because you know, when L is equal to 2 means for d orbital, okay, and 5 orbitals are 5 orientation are possible. -2, -1, 0, +1 and +2 possible orientations are there. Okay, and they're basically that d orbitals are double lobed, dumbbell shaped. Means just see, this one is also look like dumbbell shape, but lobes are 2, it's a double lobe. Okay, structure. Now just see dxy, it's a x-axis, y-axis and z-axis, so this structure is of dxy. Okay, another one is dyz, just see the structure, double lobe structure, it's a dyz structure. Then dzx, okay, this one is along with y-axis and in between, okay, x-axis and z-axis, this is structure. Then another one is dx square minus y square, and last one we have dz square. Okay, now just see dz square, it's a single lobed structure, all are double lobed dumbbell shaped structure, but this one is single lobed structure and another ring is fused around this single structure. Okay, this one is dz square, and because this one is along z-axis, so this one is dz square. Okay, now in case of f orbital, okay, actually their structure have more folds and their diagram is difficult to draw on paper, so that's why their diagrams are not given, क्योंकि उन्हें बनाना कैसा है, काफ़ी मुश्किल है, that's why they are not given in your syllabus. Diagram we don't have, so we have to study for S, P, D, F. Okay, now after shapes of orbital, one more term is there, although on questions are important, okay, because in general, maybe in competition also, competitive exam also, question is there that how many radial nodes are possible. Okay, so wherever node word is there, it means we are talking about the region where the probability of finding electron is 0. Okay, the radial node, simple, it's a spherical surface, because either you can say radial node or spherical node, same thing. So it's a spherical surface within an orbit, okay, on which the probability of finding the electron is 0. Okay, that one is known as a spherical node or radial node. Okay, and how to calculate radial node, how many radial nodes are present? So for that we have one simple formula, that is radial nodes is equal to n minus l minus 1. Principal quantum number, azimuthal quantum number minus 1. This one is your radial node. For this one is a formula for calculating radial node. Now just see, for example, suppose you have to calculate how many radial nodes are possible, means जहाँ probability 0 है electrons के लिए. Okay, that one is how many radial nodes are possible in 3s. Just see, so simple, radial node you have to put formula n minus l minus 1, n is equal to 3 because this represents number of shell, 3, l is 0. Why? Because 3s, and for s value of l is 0. -1. That one is okay. Answer after solving this, your answer is 2. So it means in 3s 2 radial nodes are there. Okay, and in 2p 0 radial nodes are present. Okay, thank you.